So, welcome to Project Week 2. My name is Dr. Ben Drew, and I'm going to give you a brief overview of the activities that you'll be doing this week. We'll go through the brief. So, Project Week 2 is similar to Project Week 1 in that you'll be working in teams doing a particular activity defined in this brief. Unlike Project Week 1, which is focused around design processes, this week is much more around engineering analysis in the areas of structures, materials, dynamics, and modelling. And over the course of the week, you'll be working in your teams on these aspects of a project activity that's defined here. The teams are pre-allocated, and you must work in these teams. In engineering industry, often that's going to be a group activity, a team activity, and you don't get to choose your teams in industry, so that's why we're trying to replicate that here. Generally, they may be the teams that you were working with in Project Week 1 back in November, but we've had to make some small changes here and there to ensure parity across the teams. So you may be working with the same people, you may not, and obviously some of you may not have been involved in Project Week 1 because you didn't do engineering practice 1. But like I said, the teams are defined on the internet on the Blackboard site, and you must work in those teams. The peer assessment system, which I'll talk about peer assessment in a minute, is hard coded with those teams and will only work if you work in the teams that you've been assigned. So we've divided the project week into two broad themes: structures and materials and dynamics and modelling. And those two themes fit with the two first year modules: solid mechanics, materials and manufacturing, and dynamics, modelling and simulation. And the way this project week works is that you make a submission, a common submission, across both of those areas or those themes. Okay, but the mark that's generated from each of those sections will be actually fed in to those modules. And so 25% of the module mark for solid mechanics, materials and manufacturing will be the project week 2 work in terms of the structure and materials, and 25% of the module mark for dynamics, modelling and simulation will be this activity to do with dynamics and modelling from this week's activity. So although you make one submission, the actual themes or components are marked separately, and so they can be independent from each other, and obviously the marks will not necessarily be the same for both of those. So the way it's organised is that on Blackboard there's the Project Week 2 Blackboard site, and the brief and the various other bits of information are actually hosted on that site. If you go to the first year students content area along the left hand side, you can then access the mechanical aerospace and automotive folder, and in there you find the brief, you find the various other bits of information associated with this Project Week site. When we make announcements, they're going to be coming from the module specific sites, because otherwise we have to make an announcement to the whole department, and obviously the announcements that I will make or other people involved in this particular activity are going to be making is just for the students doing solid mechanics, materials manufacturing, and dynamics, modelling, simulation, or either or both. So we'll go through. In section 2, we've got the timetable. So basically, it follows the same format every day. So Monday through Friday, 9 to 11, there's going to be a facilitated session in the flat teaching spaces in Z Block. And so on your timetable, you should be assigned to a room. And in those rooms, you'll meet with your group, and obviously those sessions are there for you to make a start on your projects, to actually work through some of the various activities involved, and there will be a tutor there that will give you pointers and allow you to answer questions and those sorts of things. Okay, from 9 to 11. From 11 to 1:30, that's lunchtime, or for you to continue with your group work elsewhere in the building. And then in the afternoons, if you need it, there's some MATLAB support sessions in 4Z11 and 4Z16 that are there to help you if you need them. Okay, that's basically the format every day of the week. On Friday, we're going to be things finish at 11. At 11 o'clock that's when you've got to post your poster up. I'll talk about the submission in a minute. And then later on in the afternoon, probably from 1 o'clock onwards, we're going to be running a small competition. And again, I'll talk about that later on as well. So on Blackboard, there's obviously this brief. There's also a discussion board with specific sort of threads or started threads associated with the various different sections of the project, and also a general one. Okay, so if you're in a facilitated session and perhaps the facilitator might not be familiar with the specific activity, say you're in a facilitated session with a tutor that's that's focused on structures or materials, and you've got a question about MATLAB, then the facilitator may not have a solution for you straight away. The best place to put that would be up on the discussion board, where somebody who can answer the question will answer the question during the week. So we're checking it regularly, and you've got to remember that if you've got a question about something, it's likely that somebody else has the same question. So that's why we've got this discussion board posted up there. We can make announcements and things like that as well. And Friday's activity, like I said, there's a kit provided to you. If you've not collected your kit yet, then you can go down to the workshop, the machine shop area, and there'll be the kits available there to pick up. It's one kit per group, and the competition at the end of the week. This doesn't feed into the actual activity. There's no mark associated with it, but there are prizes going to be available. And the idea is that you build a little vehicle that follows this activity. So, like I said, I'll go through that. On Blackboard, you'll find a competition briefing document that tells you what to do and how to go about building your vehicle. Okay, so that's what's going to be happening on Friday afternoon. So I'm not going to cover in detail the specific aspects in this video. I'm just going to talk about the general sort of overview, but I'll introduce the project anyway. So the idea behind this project week activity is around a prototype vehicle in a sense, and you're going to be helping to be the design process of this prototype vehicle. And the context of that is that around delivery systems or delivery of e-commerce, online shopping, those sorts of things. The logistics chain, the chain in which that your product that you've bought online gets delivered to you or to a company or whatever, is obviously it needs to be very efficient and very cost effective. Otherwise, the cost of delivery can be huge. And one of the focuses around this is this idea of the last mile that the delivery package goes through. It's called last mile delivery, the last leg of this chain. And because of the idea is that packages get delivered between hubs, to large sorting centres, and then that last mile delivery often is one of the more costly things due to the sort of scattered nature of where things are going to be delivered. You imagine you've got something that comes into Bristol's sort of sorting depot, and then it goes out to the individual areas of Bristol, and that last section is scattered, like I said, so it's quite costly. And one of the ideas that's being argued is the fact that you could actually replace that last mile delivery with an autonomous electric vehicle. And so here's a picture of one here that like I said, you can see it's a little vehicle. It doesn't need to contain a driver or a passenger. It's autonomous, and obviously it's just basically a cupboard on wheels that will drive itself around when it gets to the delivery place. Obviously the person who's due to get the goods or whatever can obviously just access them and take the goods for themselves. Okay, so it's around this last mile delivery vehicle. And your team is tasked with designing certain aspects of this prototype vehicle. Obviously the structures and materials will be around the structures and materials of the vehicle, looking at the chassis and the strength and those sorts of things, and how you actually make the vehicle. And then the dynamics and modelling are actually around one of the sort of the driving of the vehicle, looking at how to make that as efficient as possible. So like I said, I'm not going to cover the details of the structures, but you can see we've got some diagrams in here. There'll be requirements to do things like shear force and bending moment diagrams. So we've got some explainers in here, some calculations, factor of safety calculations, deflection calculations, those sorts of things. And there's a list of objectives there, the scope, and then these are the deliverables that's required for structures. Likewise for the materials, there's a bit of information, things to consider, and then the deliverables. So you've got a description of the components, design implementation plan, and a life cycle assessment of the project. And then for dynamics and modelling, so this is where we look at for the last mile vehicle, we're looking at pulse and glide strategy. So it's the idea behind pulse and glide is that it's a driving technique where instead of applying a constant tractive force to propel the vehicle along at a constant speed, what you do is you accelerate the vehicle up to a certain upper threshold speed, at which point you can then disconnect the drivetrain and the vehicle will coast down to a low speed, and then when it gets to that lower threshold speed again, the motor will kick in, accelerated up and to the higher speed, and then again disconnects and coasts. And so a vehicle that coasts very well will achieve good efficiency because you're only using that motor for short periods of time. And in fact, if you're aware of the Shell Eco Marathon, it's a competition that runs every year. The vehicles that achieve the highest fuel efficiency in those scenarios actually use this pulse and glide methodology or driving strategy to give a very high fuel economy and energy efficiency. So, like I said, I'm not going to go into details, but again, free body diagram, Newton's second law, so this is all related to dynamics. Talk about resistance from the aerodynamics. There's equations given to you here, and some assumptions as well, and there'll be the details of the equations in there. And we talk about the tractive force, some assumptions around that, and then the task is obviously to build a MATLAB model that can be used by the manufacturer to help optimize it. Your role is not actually to optimize it; it's just to build the model. So it's so that's what you've got to do. And what we've done is we've given you a template file, so you can have a look at that. There's a flow diagram you can follow through, which matches the template file, and then obviously there's also a description. So it should be relatively straightforward for you to understand what you've got to do if you follow the diagram and make some sense of that. Okay. There's some various notes about that, and then the deliverables talk about some of the parameters that have been given to you, and the various graphs and discussion that needs to be on the poster. Okay, so that's basically the very very whistle top tour over the actual details. But I'll talk here now about some of the submission details. So the idea is that you'll produce a poster as part of the work, with half of the poster being around materials and structures, and the other half being about dynamics and modelling. And the sort of deadline, in a sense, is for 11 o'clock on the Friday. There'll be some poster boards up in the atrium and Z block, and you need to find one and post your poster on the poster board on display. Okay, because the marking process, with tutors going around, having a look at the posters and marking them there and then. Now, for moderation and scrutiny purposes, obviously this is an assessment activity that needs to go through moderation and scrutiny. We need an electronic copy of that poster, and so in PDF format. So once you've made your poster, if you save it as a PDF, and then there's a deadline after the Easter break to upload that poster at the submission point on the Blackboard site for DMS, Dynamics Modelling Simulation, or Solid Mechanics Materials and Manufacturing. I don't mind which one you do. We'll obviously collect them from both areas, and there'll be a submission point on those websites by that deadline of the 18th of April. Okay, we're going to set up the groups in Blackboard, so it'll be just one person has to submit, and that will then feed all the members of the group. Again, this is why you've got to work in your allocated groups, because those groups are going to be defined on Blackboard based on the list that I've published to you. Okay. If you're not working that group, then you won't necessarily get the right the mark. Obviously, that needs to be you need to match that up. And if you want to have a look at the marking guidelines that we're using, the marking scheme, which gives you an idea of what we're actually looking for in terms of what's on the poster, then you can go onto the Project Week Blackboard site and you'll find the marking scheme up there. Okay. Now, peer assessment. Obviously, one of the things that's important from an academic integrity point of view, and obviously the fact that you were doing an accredited thing, is the ability to extract accurate individual marks from a group work activity. Okay, and the way we're going about that is we're going to be running a peer assessment system. Okay, so we're using that to generate individual marks. So every day of the project week, I mean every day, so Monday, Tuesday, Wednesday, Thursday, and Friday, there's a link on the Blackboard site which you have to click on. And when you click on that link, you log in to the system that we've set up. And in there, it'll recognize who you are, and it'll list your fellow group members. Again, this is why you've got to work in your group. And what you have to do is basically mark your fellow group members against 3 different criteria. It's a tick box, basically. Are they engaged in the group meetings, if you had them, or was that implied if they've made efforts to cover if you haven't met or whatever? Okay. Have they contributed to the poster? So have they done some work towards the submission? And if you set up actions in the meeting, did they complete them? Okay. And your assessment of those of your fellow group members is anonymous, so you can't see how you've been assessed by your peers, unless you talk about it, obviously. But yeah, and you won't be marking yourself. So when you log in, it will recognise who you are, and it will list your fellow group members. And likewise, your other team members will log in, and they'll be the ones assessing you. Okay. So that's how it works. Like I said, it's very straightforward. It's tick boxes, 3 for each fellow member, each fellow team member, and you've got to do it every day, once per day. You log in, fill out the form, press submit, and you do that every day of the week. Okay. And obviously, you've got to. If you feel your group member engaged with the group in whatever meetings you have, completed their actions and stuff, so then you obviously tick the 3 boxes for that team member. Okay. It's worth reminding you at this point to be respectful and professional when assessing your colleagues. Okay, we don't want people to gang up and give people poor marks or whatever. But like I said, you need to you need to do this properly. Okay. Perhaps a team member is unable to make a meeting, but has made efforts to catch up and remain engaged in all activity. Then for that person, although they perhaps didn't make the meeting, they've done enough efforts in other ways that you can actually give that person a tick for attending the meeting, although they actually weren't there. Yeah, okay. So like I said, once per day you've got to do this. Okay, you've got to log in, click the link, log in and fill out the form. And at the end of the project week, we'll obviously look at the number of ticks, but that will be used to moderate the group mark for the poster. So clearly, if you choose not to engage with your group, then your peers will obviously give you no ticks, and that's not a good way to evidence your contribution to the work. Okay. So like I said, once per day you've got to do it. Please check the form before you click submit. Make sure you've actually answered the questions. Okay, because once you click submit, that's it. You can't go back and redo the form for that day. So you've only got one opportunity to do it. Okay, and you can't go back and change your marks if you decide you want to. Like I said, as a part of the group work activity, you're expected to meet regularly throughout the week. So either in person, and it's a good idea in those meetings to set out actions and identify those who are responsible for completing an action. Obviously, that makes that aligns with the ticks that you've got to do. Okay, and remember that by not ticking one of the boxes, that will impact your fellow team members' marks. Okay, and clearly, if you feel that all members contributed equally, then all members should tick all the boxes every day. Okay, it's quite straightforward. If you're a part-time student, then there's a slightly different brief, but I will have contacted you in that case, so don't worry too much about that. Then I've listed some frequently asked questions. There's a number of you will be retaking one or both of the 3 modules. Of the modules. That shouldn't be 3. Okay. There's only 2 modules involved. So if you're only taking one, or if you're retaking one or the other or both of the modules, Obviously, for both of the modules, you just do the project week activity as you were before. Okay. If you're only taking one of the modules, so either solid dynamics modeling simulation or solid mechanics materials and manufacturing, then clearly you only need to do that bit that's relevant to the retaking, because, like I said, these parts are distinct, they're marked separately, and they feed into the different modules. If you're not doing solid mechanics materials and manufacturing because you passed it last year, but you are doing dynamics and modeling simulation, then you only need to do the dynamics and modeling section of the work, and vice versa. So if you passed dynamics and modeling simulation last year, but you're retaking solid mechanics materials and manufacturing, then you only do the structures and materials bit of the project week activity. Okay, and so the peer assessment system that I've just described, this is how we're dealing with if a team feels that they're aggrieved because it's mismatched work, then obviously you can actually use the peer assessment system to sort of record that, and that will be taken into account when we moderate the marks. Okay, so that's some details, and then we've got about the assessment. So as I mentioned, you've got a poster with two halves. One feeds into solid mechanics materials and manufacturing, the other one is into dynamics modeling simulation. And in the poster, you've got the heading, that'll be a group number, student names, student IDs, and if you want to give an idea of the approximate contributions up there, you can do that. Okay, the poster should be A1 sized in portrait orientation, with each half being A2 in landscape. So the first half, structural materials, A2 landscape, that's the structural materials section, and then below that you've got A2 landscape for the dynamics and modeling section. Okay, you can set up an A1 size poster using PowerPoint or whatever, something like that. Okay, and that's where you can post all your content, and then, like I said, it's quite straightforward then to export that poster as a PDF to make that submission. And if you want to print it out, you can obviously print it out using multiple sheets of A3 or A4. Okay, and to make up the poster that you're going to post on the board, or if you want to take advantage of the plotters and things that we've got around on campus, then you can go and get a poster printed somehow as well. Okay, but like I said, it's up to you how you want to build up the poster. Like I said, multiple sheets of A3 is perfectly acceptable as long as it makes sense and it's quite straightforward to understand what's on what sheet. Okay, and as I mentioned, so at 11 o'clock on Friday the 31st, we want the posters up in the atrium, and you need to make a submission of an electronic copy of that by 2 p.m. on Tuesday the 18th of April. Okay, and as I mentioned, the guidelines. Okay, so that's basically the brief. I hope you enjoyed the week. Like I said, take a look on Blackboard. There'll be plenty of information up there. We've got obviously this brief is up there. We've got the data that the students need. We've got the group lists, and there's obviously information around the competition as well. Like I said, there's some guidelines up there about what you've got to do. You've got to pick up your kit on the morning on Monday. One kit per group, and you should have fun with the competition. Okay, so thank you very much. If you've got any questions, then you can send me an email, or any of the other tutors involved. Obviously, Ian and Amir are responsible for the solid mechanics, materials and manufacturing section of this work, and it's Bayang and myself are responsible for the dynamics bit. So if you want to drop us an email if you've got specific questions, then you can do so. Okay, thank you very much.